Good morning, good afternoon, good evening. We are indeed back and better than ever. This is part two, the sequel to the shortest distance from a line to a point. Just two examples to do. On the map shown, the distances are measured in kilometers. Ship R is moving in the direction 3, 4. So here's ship R, and always think about it, up 3 to the right 4. That's the direction the ship is moving. At 10 kilometers per hour. You have to always pay attention to this relationship, and you'll see why in a second. But remember, this is the velocity vector, which is different from the actual speed. Okay? We'll see that in a second. Write an expression for the position of the ship in terms of t, the number of hours after leaving port A. So for part A, we are looking for R equals A plus TB. So we need a directional vector and we need a starting point. We have the starting point, which is -8, 3. We just need a directional vector, which you probably think is 3, 4. But here's the rub, okay? We don't know if the directional vector 3, 4 gives us a speed of 10. In other words, we have to check to see if the magnitude of 3, 4 gives us a speed of 10. So let's find the magnitude of that, and that would be square root of 3 squared plus 4 squared, which is root 25, which is 5. Ooh, 5 is half of 10, so we're going to need to double this velocity vector. So 2 times the vector 3, 4 is equal to 6, 8. Oops, why do I always, I hate when I do that, make it a fraction. The vector 6, 8, okay? And to double check, let's check the magnitude of 6, 8, which would be 36 plus 33 to the 6. 36 plus 64 equals root 100, which is equal to 10. Perfect, that's the speed we want. So our nice little equation is going to be xy, and you could leave it as r if you want. The boat starts from the point -8, 3 plus t multiplied by our velocity vector, which is 6, 8. Very cool. And something else I want to show you, the vector from the origin 0, 0, OR, see this right here, is equal to OA plus AR. You can see that geometrically. This plus this equals this. So I just wanted you to see that because that's exactly what's happening here. Okay, so we have that. Find the time when the ship is closest to the port P 10, 2. Well, that is going to happen when PR is perpendicular to AR. In other words, we got to find this point R right here. Okay, so let's work on part B. How do we go about doing that? So we need PR perpendicular to the vector, the directional vector 3, 4. And you might be thinking, hey, Mr. B, why don't you use 6, 8? Well, you can use either one when you're only talking about direction, because these directions are equivalent because 6, 8 is a multiple of 3, 4. And I'd rather work with PR and with 3, 4 instead of 6, 8. The numbers are smaller. Okay. So the vector PR, what do we know about PR? Well, this is 10, 2. And the vector r, I'm going to put up here right above the point, we know has x-coordinate -8 plus 6t. So -8 plus 6t. And it has y-coordinate 3 plus 8t. 3 plus 8t. Oh, I just crossed off the c. How are we ever going to know that this is the c? I don't know. So that means that vector PR is equal to, let's see, this is our -8 plus 6t minus 10. So that becomes, let's see, negative 18 plus 6t. And then what do we have? 3 plus 8t minus 2. So that's just going to be 1 plus 8t. 1 plus 8t. Make sure I got that right. Yeah, okay. And we need dot 3, 4 to be equal to 0. So we would get 3. Why do I keep doing that? You guys need to yell at me. Dot the vector 3, 4. So 3 times negative 18 plus 6t plus 4 times 1 plus 8t must be equal to 0. And you have to trust me that when we solve that, we get t equal to 1. Okay? Back to the question. Find the time when. We don't have to find the coordinates, just when. And this is the time. It is in hours, which we've already been told. So the answer would be 1 hour after leaving the port. If we had to find these coordinates right here, we would just replace the vector t and the vector pr. Okay, last example. Consider the point P, negative 1, 2, 3, and the line with parametric equations, blah. Find the coordinates of the foot of the perpendicular from P to the line. We're making sure you get lots of practice here. Okay, so this line has the, okay, so this is part A. So this line has direction vector B of the directional vector 2, 3, 1. Where did I get that? Those are the coefficients of my t's in my parametric equation. Okay, so let's let A be any point on the line. So then the vector, the position vector for that would be 1 plus 2t, right here, negative 4 plus 3t, and 3 plus t. Okay, so that's any point on this line. Okay, so we have A, and we have some point P, right? And we need this to be perpendicular to find the, to find this foot here. Okay. Okay, now what? Well, don't we need PA dot B to be equal to 0 in order for them to be perpendicular? Two vectors are perpendicular if their dot product is 0. So let's rock and roll. So then this dot that is going to be 2 times 1 plus 2t plus 3 times negative 4 plus 3t plus 1 times 3 plus t, and that must be equal to 0. Okay, so trust me when we solve that and we get t equal to 1, and then I get so busy doing this I forget what it is that we're looking for. Okay, we're supposed to find the coordinates of the foot of the perpendicular, where the coordinates are A, and we can get those points because this is going to be the x coordinate, the y, and the z if I write it as a coordinate. So 1 plus 2 is 3. Negative 4 plus 3 is negative 1. All I'm doing is replacing t with 1, boys and girls. And then 4, 3 plus 1. So the answer is 3, negative 1, 4. Okay, so B, now we find the shortest distance from the point to the line. Well, that is going to be the vector PA, or the magnitude of PA. Okay, well, first I have to find the magnitude. I have to find vector PA. Well, vector PA is going to be 1 plus 2t and minus a negative 1. So that's 1 plus 2t minus a negative 1, and then negative 4 plus 3t. Why did I do that? I know that minus negative 1 is plus 1, right? Negative 4 plus 3t minus 2, and then 3 plus t minus 3. But we know that it's perpendicular when t is equal to 1. So replacing t with 1, I have to take the magnitude of, let's see, this is going to be 4, negative 3, 1. Okay, and that's replacing t with 1. And that is equal to the square root of all of those guys squared. 4 squared plus negative 3 squared plus 1 squared is equal to square root of 26. So we don't have units. Find the shortest distance from the point to the line. That is going to be the square root of 26 units. That is all I have for this. I hope you enjoyed it. We will see you next time. Becker is out!